So this is probably a quite different experience. This is going to be much more corporate. And I think the take-home message is going to be, when you are working in a company environment, you don't get the freedom to choose your problems, and you don't get the freedom to choose what sort of business the company is in. So many of the solutions that you see in the research literature, like Thomas's just now, are highly appropriate when you're dealing with large consumer-facing companies with very big data. Not everybody lives in that world all the time. I was an academic for a long time before I started doing this, and so this is news for me. So you'll see there's a little statistics, a little machine learning in here, not so much. Okay, so what I'm going to talk to you about is how NLP came to be part of the solution to a business problem. And in order to talk about that, I'm going to have to talk to you about the problem, about the technologies that are prevalent in the company. If you want a demonstration, come and see me. The wireless here isn't quite good enough for a live demo. I just tried it on the way through, and nobody would enjoy it. And then as I go, I'll try and tell you something about what it's like to be fundamentally a scientist working in this sort of environment. So I hope this proves to be interesting. I did lots of things, and I'll go over that. You can see the slides later. They'll be distributed, available. I have to say this, you know that. Okay, so what does Thomson Reuters do? It offers people information, usually not for free, and usually intended for people who have some professional... Still good? Okay. Usually for people who have some sort of professional background, so lawyers, tax accountants, research scientists, arguably professional background, financial traders. But people with specialized skills who want specialized information. And there are lots of different products, each catering to their own segments. So, as I said, this is not Facebook, this is not Google, it's nothing like that. It's not... Doesn't seem to like me. Maybe I need to do that. Let's try that. So there are an awful lot of people who are in the business of delivering a product which is expensive for the customer and which the people are paying a lot for, thousands of dollars per seat. So there are plenty of people whose primary skill is interfacing with those professional users and helping them to be happy. Part of the reason why people do this is because they want a relationship with a company which will take seriously things like privacy and data security. So many of our customers, particularly the American lawyers, never sign an agreement like which we've all agreed to in order to use free internet services about we can use your clicks any way you want. Lawyers are not looking for that. They're looking for, we will help you understand how we want you to use our clicks, but you can't just go aggregating them over thousands of people. It's not going to happen. So it's not one size fits all, and the technology job is get a good connection to products. This is us. One of the things you should know, this is a quantitative environment, is that there are about 50 people doing research and development, some of it more theoretical, some of it more applied, in a company of 50,000 people. So, okay, we have limited resources, we have to choose our battles. So we need to find the businesses where we're going to make a difference. And this is part of our effort to do so. There are 5 of us now in London, nobody yet in Prague in research. I'm sure we could change that over time. The big office is in Eagan, Minnesota, which is a suburb of Minneapolis. And that really comes about because the law business was based there and has a large office there. So That's where a lot of our successes have been. Now, most people from our background have heard of the Reuters corpus, which is a collection of newswire that was put out in the 90s. And so most people, when they hear the name Reuters, believe that what they're dealing with is a news business, and that is true. But it's also true that we're dealing with a business which has a very large financial component, dealing both with financial traders and advice about how to respond to risks like what happens when there are floods in Thailand, or what happens when it turns out that my bank customer is actually somebody who is a war criminal. The answer is you get into trouble, so you have to catch that before it happens. As I say, there's a legal business. There's also an intellectual property and science business which does things like journal impact factors, drug development support, information company. We don't develop drugs, we help people who develop drugs. So various different things, and quite a lot of different technology choices. So there are loads of databases. They tend to be standard Oracle databases. There's a lot of search. It tends to be built on top of Lucene through Elasticsearch. We don't have GPUs all over the place. We have enough computing support. We try and do what we can. There's a tendency for each of those little divisions of the company, which are not little, to go their own way. So there's a lot of databases which are not done in quite the same way in different places. And what we've begun to notice is that people are starting to ask for things which cross-cut our beliefs about how the business is organized. So we collect information which we thought of as relevant to people who are doing drug development about which companies are doing what, which companies have drug trials doing what, at what stage they are, and things like that. Guess what? The financial traders are interested in this because if they find that somebody has just failed a drug trial, they're very keen to say, I think we should sell that share. Or conversely, if they find they've discovered a wonder drug, they're very keen to buy the share. So that's a problem because it means that the users for whom the database was designed and who've learned how to use it are not the ones who we're trying to serve all the time. So this was the corporate initiative, not my story, but other people's story. Big, open, linked data. Clearly a good idea. The knowledge graph. Clearly a good idea because Google has one. Yes, so we have one too. And what it says is, look at the colors, and what you can see is that dramatizes what I was showing before. There are links between the different databases which are unexpected. So we have a challenge about how we're going to respond to that. And one of the places where this happens is exactly the drug company thing. So although I said that the professional users, you might think that they were the kind of users who were prepared to learn a complicated technology because it was going to pay off for them in everyday life. This is not always true. Sometimes they are beginners, drive-by users, if you will. So a first-time user is going to ask broad questions, doesn't really know what's in the database, but kind of suspects that there might be something good. How do they access it? Status quo ante, read the documentation. I can't understand the documentation. It's written for somebody else. Or an expert user who has a pretty good idea what they want, but might benefit from a bit of guidance. And we're trying to serve both these things. Notice that this is information search in the context of a real task which you're trying to fulfill. So just as with web users, one of the underlying things is detecting user intent. Unlike web users, the way we're going to know about user intent is because we have experts who are skilled in understanding it, not because we're able to aggregate over hundreds of thousands of documents. So what do we do? Well, we'd like to show people things like this. We'd like to say, here is the distribution of patents by assignees. And the very, very simple, impactful analytic gives you the picture. This particular breakdown of the market, Takeda seems to be a big player and the other ones are smaller. In order to do that, we've created this system which we call TR Discover, which, as it says in red, enables discovery of behavior, of data. And the idea is we'd like people to be able to type queries, get back information which shows them something about what they might be able to query, and do their job. Okay. Can't do a demo because of the Wi-Fi thing, but I can show you some pictures. So what you can see over here, this is what the first-time user might experience. They start by typing D, thank you, and then they say, okay, well, D could be completed as just finish that. They're really typing D, do the search. Or it could be drugs, or it could be drugs using, or it could be drugs having a secondary indication of. Then once the user types drugs, it sees either go now, or using, or having a secondary indication of, or manufactured by, which we select. And that goes straight ahead to suggestions of some things which might usefully complete the query. Both specific companies like Pfizer and the National Institutes of Health, not really a company, but move on, or generic things like show me all companies. We're going to have different analytics if we show all companies than if we show one company, obviously. And this is what might come back. We might say something like, here are 10 or so companies. Here are color codes for the different phases of drug development. And this will tell us something about what's going on. This is for some set of graphs. Okay. Another one like that. I'll move quickly through. I told somebody that we don't do sentiment analysis, but that's a lie. We do. And the reason we do it is because it's a potentially useful piece of information which summarizes things that you might want to know about companies like Novartis. So we can see that something pretty remarkable happened to Novartis between 2014 and 2014-02. I'm not trying to interpret this. One of the many things we deliver. Similarly, that one. Okay, how is this done? Well, it's pretty standard stuff, most of it. Many of you may know the NLTK toolkit, which is a packaging up of many very nice natural language capabilities in Python. What we take from that is basically the grammar algorithm. At the moment, we're actually also running their parser, but we're close to running our own parser, which will do the same thing. This is not machine learning, it is real logic-based formal linguistics. The applications of machine learning at Thomson Reuters which really play are named entity recognition, it's very important, recommender systems, certain amount of sentiment analysis. So fairly low-level stuff which can be applied straightforwardly to all the markets. This particular one, the reason why we're going with the logic-based route is that, first of all, remember where our knowledge is coming from. Our knowledge is coming from people who are expert in the domain. So we're going to need to capture information about people in the domain, and a natural way to encode that is in a grammar and then in a mapping to a database schema. So we generate something which represents the meaning of the sentence. We analyze the grammar and the meaning, and we use some heuristics based on the databases to decide what's going to happen. Okay, so this is the grammar. It's not going to win any prizes as linguistics, nor is it going to win any prizes as statistical NLP, but it has some strengths. One of the strengths, as I say, that it produces real logical semantics understood in a sensible way. Another strength is that it's actually written in such a way that it's going to be very reusable across domains. So this is not immediately obvious, but actually most of the material which gets combined is contained in the words. It's strongly lexicalized. And if you live in the world of theory, you want the number of rules to combine words to be something like 6. If you live in it turns out to be 160, but those 160 stay the same throughout, pretty much, apart from strange things like what happens with the word by, which in fact contains a lot of information about the relationships between one word and another. So that's what I mean by prepositional phrases have features that enforce very tight attachment representative preferences. One of our entries for by is something which says, when two words are connected by, one of them is a participant in a court case who is either the defendant or the prosecution or the person doing the prosecution, and the other one is a lawyer. That's what by means for us. So see that what we're in the business of doing is putting professionally relevant information into this tool in a way that will make sense. And we don't like things like drugs headquartered in the US, because it can't happen, so we encode it that way. And this is the kind of stuff that we get as a meaning. So this actually says, for all X, there is a drug called X, and an organization which is called ID 042, which develops X. And ID 042 is a company, and ID 042 is, I think, the speaker from this morning's company, Merck. I talked to him, and he said there are more than one Merck company, and so I can't be totally sure, but I think it is. Okay. And then the next step is to take this and translate it into Sparkle. So this is what bridges the gap between the meaning representation and the knowledge sources from which we need to pull the answer. Benefit of having the explicit knowledge representation is that we can use the explicit meaning representation to tell people what sort of thing we're likely to find in the databases. Then the real world hits, and we say, we want to do Sparkle because it's a knowledge graph, and we like generic databases, and we'll connect it to a triple store of some sort. And we have a lot of words in our grammar, and that doesn't work. So we take the words that we really want, stuff them in an in-memory SQL database, and Bob is your uncle, as they say. So a bit of practicality. Yeah, we know it won't scale. I'll skip that. Okay. No, maybe. Wait, whatever. Ah! I need to go back. What have I done? That's better. Yeah, thank you very much. Okay. Now, that's how the autosuggest works. So this is where there is some very slight new machine learning and statistical learning. The system is not yet deployed, so we don't know how people are going to use it, so we don't have query logs. We might get query logs one day. For the moment, what we're saying is, if we want to choose which concepts to show, which companies to show if we know it's a company, we're going to show them the ones which are popular. And what we're going to mean by popular is occur a lot in our databases. So that's what we do. Once we have large enough query logs, we'll certainly add in an Ngram model. Thank you very much. And that will probably help. This thing is going forward in various ways, and that's fine. Okay, now, I've worked for 3 companies, and I think it's probably worth saying something about how they're different. So the Educational Testing Service is a non-profit. Part of its mission is to give back to education. So it came out that they do a mix of really quite blue sky research in educational testing, thinking what might conceivably be possible. And there are also some moments where it acts more like Mr. Burns from The Simpsons. You know, release the hounds, that kind of stuff. Nuance is a very successful speech technology company serving a lot of the people who want to buy speech technology. Not everybody buys speech technology. Microsoft don't, typically, but many do. One of the things that's different is that if I pick a random employee at ETS, they're an educationalist. If I pick a random employee at Nuance, they're an engineer. I can talk to them. Great, it's easy. If I pick a random employee at Thomson Reuters, I don't know what they do. I know they're smart. I know they're good at doing something, but I have no idea what it is. If I talk to them about a development set, a test set, and a training set, you can kind of see their eyes cross, and they're going, "Where's the bar?" You know. So it's a different world, and what I found I need was things that I hadn't known I would need, which is people skills, willing to understand that somebody else does have something to contribute, but you don't yet know what it is. So this is a hard lesson to be learning, but it's worth learning. And that's where I'll stop. Thank you.
I'd like to ask you, how do you deal with the problem of slow speed of Sparkle queries?
Well, the short answer is don't use it. It depends. You know, one of the things that it depends on the person. You know, so for the demo, we don't have a need to deal with large simultaneous users. So we don't really have a need to scale, which is the benefit of Sparkle and all sorts. But we do need to have acceptable latency. And because we're doing auto-suggest, if it is very slow, it's painful. So we thought when we started that possibly parsing production of logical form would be the rate limiting step. It's not. Even with smallish databases, the database query dominates. So yeah. So the short answer is it depends on your use case. Sometimes you have to.
Thank you. Any other questions?
Hello. Very interesting business. I would like to ask you, what is the size of or structure of your databases? Like, what is the diversity? What is the size of the data you are processing in your business?
Okay, well, some of those answers I'm explicitly not allowed to give you. In fact, I think I probably shouldn't say anything quantitative at all. But one thing I will say is that in the legal business, most of the lawyers in the US buy both our product and our competitor's product. So there are hundreds of thousands of lawyers in the US using our tools. And there are quite a lot of financial traders in London. So the constraints on the businesses are quite different. The lawyers very much want to get the right answer, and they care a lot about audit trail because their business model is that they will do some work for their lawyers, they will give it to their clients, they will give the results to their clients, and they will submit billing saying, effectively, we checked all the boxes, we've done the lawyer thing. So they don't care very much about speed, but they care an awful lot about accuracy. Whereas the constraints on the financial traders are, we don't really care if it's always right, but we want it to be there within 150 milliseconds. So we're not using the same database technology. So I couldn't give a one-size-fits-all answer. even if I knew, which I don't.
Another question?
Yes.
So, what do you think about automating the simple lawyer tasks with, intelligence, artificial intelligence?
Yes, I think there are plenty of good things to do. There are some things which are already being done. So there are quite a lot of tasks which reduce to checklists. And we have parts of the legal product called Practical Law, which is built around having people work through the checklists. So there are a number of things we can do with lawyers which other people won't do. So we have people designing those checklists. It's basically simple automation. It's not really AI in any very deep sense, but it makes a big difference in people's lives. And the other place where we use expertise a lot is that we do have numerous thousands of people who are qualified lawyers who are going through helping to index cases and documents so as to make sure that the metadata associated with those which feed into the search engine are actually good.
So, are you going to disrupt the market of the the lowest hanging fruit of the lawyer or attorney advice for the general population?
That's a very good idea.
Yeah.
That's a very good business.
Thank you.